Close your eyes for a moment. Imagine you are sitting outside on a warm summer evening. The sun is starting to hide behind the hills. The sky turns a soft orange, then a deep purple, and finally it becomes dark. In that darkness, everything changes. You cannot see the trees, the path, or the faces of your friends. But then, someone starts a small fire. A tiny spark jumps, a flame grows, and suddenly the world returns to you. My friends, have you ever stopped to wonder, what is this magic we call light? For the first humans, light was everything. It was the difference between life and death. During the day, the sun was their great king. It gave them warmth and showed them where to find food. When the sun went down, they looked up at the moon and the stars. They felt a sense of wonder. To our ancestors, light was a mystery. It was a gift from the gods. They noticed how light moved. They saw how it created shadows that grew long in the afternoon. Think about this. For thousands of years, humans could only make light with fire. We lived by the rhythm of the sun. When the sun woke up, we woke up. When the sun slept, we slept. But even then, our minds were curious. We watched the way light danced on the surface of a lake. We watched the way a rainbow appeared after a storm. We didn't have science books back then, but we had our eyes and our hearts. We felt the warmth of the light on our skin and knew it was special. Light was our first teacher. It taught us about time. It taught us about beauty. And most importantly, it made us want to ask, why? Why does the sun shine? Where does the light go when we blow out a candle? Tonight, we are going to follow that curiosity. We are going to travel through time to see how light changed from a holy mystery into the greatest tool of human science. So, let's go back, far back, to the time when we first began to look at the light and truly see it. Imagine you are in ancient Greece or the golden deserts of Egypt. The smartest people in the world are sitting together, looking at the sun. They are asking a very simple question. How do we see? Today we know the answer, but back then it was a huge puzzle. Some famous thinkers, like a man named Empedocles, had a very strange idea. He believed that our eyes were like flashlights. He thought that light actually came out of our eyes. Imagine that. He believed our eyes sent out invisible feelers or beams of light. When these beams touched an object, like a tree or a bird, we could see it. It sounds like a superhero story, doesn't it? But then other people asked a smart question. If light comes from our eyes, why can't we see in the dark? This made everyone think again. In the city of Alexandria and across the Arab world, scholars began to look closer. They realized that light must come from outside of us. It comes from the sun or a lamp, bounces off an object, and then enters our eyes. One of the greatest thinkers in this story was a man named Alhazen. He lived about 1,000 years ago in Cairo. He didn't just guess, he did experiments. He sat in a dark room and watched how light traveled through a tiny hole in the wall. He noticed that light travels in straight lines. Think about a sunbeam coming through a window in a dusty room. You can see the straight path it takes. Alhazen realized that our eyes are just receivers. We are like cameras, catching the light that the world throws at us. This was a huge change in how we understood the world. It meant that light was a physical thing that moved through space. It wasn't just a feeling or a magic beam from our eyes. It was a traveler. My friends, imagine the excitement of these early scientists. They were like detectives trying to catch something they couldn't touch. They began to realize that light follows rules. It has a path. It has a logic. And if it has a path, they wondered, how fast does it move? Does it happen instantly? Or does it take time to get from one place to another? For a long time, most people thought light was instant. They thought that the moment you lit a candle, the light was just there, everywhere at once. Even great scientists like Galileo tried to measure the speed of light by standing on hills with lanterns, but light was much too fast for them. Then we go to the year 1676. A Danish scientist named Olaus Romer was looking at the stars, specifically at Jupiter and its moons. He noticed something very strange. Sometimes the moons of Jupiter appeared exactly when they were supposed to, but at other times of the year, they were a few minutes late. Romer didn't think the moons were being lazy. He realized that when Earth was farther away from Jupiter, the light had a longer path to travel. Think about that for a second. Light was late because it had a longer walk to get to his telescope. This was the first time anyone proved that light has a speed. It is not instant. It is just very, very fast. How fast? Well, let's use our imagination. If you could travel at the speed of light, you could go around the entire Earth 7 times in just 1 second. It is the fastest thing in the universe. When we look at the sun, we aren't seeing it as it is right now. We are seeing the light that left the sun 8 minutes ago. If the sun suddenly disappeared, don't worry, it won't. We wouldn't know for 8 whole minutes. We would still see its light for a little while, like a beautiful memory. Understanding the speed of light changed everything. It told us that space is huge. It told us that light is a messenger. It carries information from the past across the empty darkness of the universe. Scientists began to ask, if light is a traveler moving through space, what is it made of? Is it like a stream of water? Is it like a group of tiny hummingbirds? Or is it something else entirely? The mystery was getting deeper, and the world was about to enter a great debate that would last for centuries. My friends, imagine 2 of the smartest people in history standing on a stage having a big argument. On one side, we have Isaac Newton. You might know him as the man who discovered gravity when an apple fell on his head. Newton looked at light and thought, this must be made of particles. He imagined light was like millions of tiny invisible marbles or corpuscles shooting through the air. Why did he think this? Well, because light travels in straight lines and bounces off mirrors, just like a ball bounces off a wall. To Newton, light was a physical shower of tiny objects. But on the other side of the stage, we have a man named Christian Huygens. He had a completely different idea. He looked at the way light moves and thought, no, Newton, you are wrong. Light is a wave. Think about a pond. If you throw a stone into the water, you see circles of ripples moving outward. Those are waves. Huygens noticed that when light goes through a small hole, it spreads out, just like water waves. He believed that light was a vibration, a ripple moving through an invisible ocean that fills all of space. For 100 years, people didn't know who to believe. Newton was very famous, so most people thought he was right. But then, other scientists did more experiments. They saw that when 2 beams of light meet, they can actually cancel each other out or create beautiful patterns, just like 2 waves in the ocean meeting. Imagine the confusion. If light is a particle, it's a thing. If light is a wave, it's a movement. Which one is it? Can it be both? This debate wasn't just about science. It was about how we see the very fabric of our world. Is the universe made of stuff, or is it made of energy and movement? Think about this the next time you see a rainbow. Those colors are there because light is acting like a wave, bending and stretching. But when you feel the heat of the sun on your hand, it feels like something is hitting you, like Newton's particles. This mystery stayed with us for a long time. It was a puzzle that needed a new kind of thinking to solve. And that new thinking would come from the world of electricity and magnets. As we move into the 1800s, the story of light takes a very exciting turn. Scientists were starting to play with electricity and magnets. They were discovering that these two things were like brothers. They always traveled together. A brilliant man named James Clerk Maxwell began to write down the rules for how electricity and magnetism work. He discovered something that shocked the world. He found that when electricity and magnetism dance together, they create a wave. And when he calculated how fast that wave moves, he found a familiar number. It moved at exactly the speed of light. Maxwell realized something beautiful. Light is not just a wave in water, it is an electromagnetic wave. It is a ripple of pure energy. Imagine it like this. We are surrounded by invisible waves. Right now, there are radio waves, Wi-Fi signals, and X-rays moving through the air. You can't see them, can you? But they are there. Light is simply the only part of this big family of waves that our human eyes can actually see. Think about a giant piano. The piano has many, many keys. Most of the keys make sounds that are too high or too low for us to hear. But there is one small section in the middle of the piano that we can hear perfectly. Light is like those middle keys. It is just a small, colorful part of a much bigger song of energy. This was a massive discovery. It meant that light, electricity, and magnetism were all part of the same thing. Light was an invisible dance that became visible to us. This helped us understand why light can travel through the empty vacuum of space. It doesn't need air or water to move. It is its own energy. It carries its own road with it as it travels. But even with this amazing discovery, there was still a problem. Maxwell proved light was a wave. But Newton's old idea about particles wouldn't go away. Some experiments still showed that light acted like a solid thing. The story was about to take a quantum leap into the modern world. At the start of the 1900s, scientists were stuck. Their old rules weren't working anymore. They were trying to understand how light comes out of hot objects, like the red glow of a toaster or the yellow light of a fire. A man named Max Planck had a crazy idea. He suggested that light doesn't come out in a smooth, continuous stream like water from a hose. Instead, he said it comes out in tiny packets. Imagine you are buying sugar. You don't just buy some sugar, you buy it in bags. Planck called these bags of light quanta. Then, a young man working in a patent office named Albert Einstein took this idea even further. He was looking at a mystery called the photoelectric effect. This is a fancy way of saying that when light hits a piece of metal, it can sometimes knock electrons, tiny bits of electricity, off the surface. Einstein realized that waves couldn't do this easily, but packets of energy could. He called these packets photons. Imagine light is like a stream of tiny energetic ping-pong balls. Each ball, each photon, carries a little bit of energy. When they hit the metal, they kick the electricity out. So, after hundreds of years, we finally found the truth. Is light a wave? Yes. Is light a particle? Yes. It has a double life. Sometimes it acts like a ripple in a pond, and sometimes it acts like a tiny ball of energy. This was the birth of quantum physics. It's a world where things can be two things at once. It's a bit confusing, isn't it? But it's also wonderful. It shows us that the universe is much more creative than we ever imagined. Think about the solar panels you see on people's roofs. Those panels work because of Einstein's discovery. They catch the photons from the sun and turn them into the electricity that charges your phone. We had finally learned what light is. Now it was time to learn what we could do with it. We were about to take light into our own hands and change the world forever. For almost all of human history, when the sun went down, the world went dark. We had candles and oil lamps, but they were dim and smoky. But once we understood the science of light, everything changed. In the late 1800s, inventors like Thomas Edison worked hard to trap light in a bottle. They created the incandescent light bulb. Do you remember that warm, yellow glow of an old light bulb? It worked by running electricity through a thin wire until it got so hot that it started to shine. Suddenly, humans could stay awake and work or play long after the sun went down. Cities began to glow at night. This changed our lives completely. We became a 24-hour world. But we didn't stop there. Scientists kept looking for better ways to make light. They created fluorescent lights, those long, bright tubes you often see in offices. Then they created LEDs. Think about the tiny light on your phone or the bright screen of your computer. Those are LEDs. They are amazing because they don't get hot like Edison's old bulbs. They are much more efficient. They turn almost all their energy into light, not heat. And then there is the laser. Have you ever seen a laser pointer? A laser is a special kind of light where all the photons are marching in the same direction, perfectly in step. Normal light from a lamp goes everywhere, but laser light is a perfect straight line. We use lasers for so many things today. They help doctors perform surgery, they read the barcodes on your food at the supermarket, and they carry internet data through long glass cables under the ocean. Light is no longer just something we observe. It is something we build with. We have learned to bend it, focus it, and use it to send messages around the world in a heartbeat. From a simple fire in a cave to the LED screen in your pocket, light has become our most important tool. But even as we use it on Earth, light is still doing its original job, telling us the secrets of the stars. Let's look up again. When you look at the night sky, you are looking at a giant history book. Remember what we said about the speed of light? Because light takes time to travel, looking at distant stars is like looking back in time. The light from some stars has been traveling for hundreds, thousands, or even millions of years to reach your eyes. When you see a star, you are seeing it as it was in the past. That star might not even be there anymore. It's like receiving a letter from a friend that was mailed many years ago. Astronomers use huge telescopes to catch this ancient light. These telescopes are like light buckets. They sit on top of mountains or float in space, waiting to catch a few photons from the very beginning of the universe. By studying this light, we can learn what stars are made of. Each color of light tells a story. It's like a secret code. When we look at the light from a distant planet, we can tell if it has water or oxygen. We can tell if it might be a home for life. Think about the James Webb Space Telescope. It is out there right now, catching infrared light, a kind of light we can't see with our eyes, but we can feel as heat. This light can travel through clouds of space dust to show us where baby stars are being born. Light is our cosmic messenger. Without it, the universe would be a dark, silent mystery. But because light travels, the universe is open to us. It invites us to explore. Every time a photon hits a telescope's mirror, it brings a piece of news from 1 billion miles away. It tells us that we are part of something huge. It tells us that even though we are small, we can understand the giant dance of the galaxies. Light bridges the gap between us and the furthest corners of space. It is the thread that connects our small blue planet to the rest of creation. And the more we look, the more we realize that the story of light is far from over. We have traveled a long way together, haven't we? We started with the first humans huddled around a fire, and we ended with telescopes looking at the birth of the universe. Light has been our constant companion. It is the most common thing in our lives. but it is also the most mysterious. It is a wave, it is a particle, and it is the speed limit of the entire universe. But, my friends, do not think that we know everything yet. In science, every answer usually brings 10 new questions. Today, scientists are still studying light to solve the biggest mysteries of all. They're looking at dark matter and dark energy, things in space that we cannot see because they don't give off any light. How do we study something that is invisible? That is the next great challenge. We are also learning how to use light in new ways. Imagine computers that use light instead of electricity. They would be faster and cooler than anything we have today. We are learning how to use light to heal diseases and to create clean energy for everyone on Earth. Light is a symbol of hope and knowledge. Think about the phrases we use in English. We say, "I see," when we finally understand something. We say someone is bright when they are smart. We talk about a light at the end of the tunnel when we are going through hard times. Light is more than just physics. It is a part of how we think and feel. It gives us comfort, it guides us home, and it pushes us to keep searching for the truth. So, tonight, when you turn off your lamp and go to sleep, remember the long journey that light took to get to you. Remember the ancient Greeks, the Arab scholars, the inventors, and the stars. The story of light is really the story of us, the story of human curiosity. And as long as there is a spark of curiosity in your heart, the light will never truly go out. Thank you for joining me on this journey. Keep looking up, keep asking why, and keep shining your own light in the world. Until next time, my friends.